Okay, we're going to talk about another way that we can take two equations, or sometimes we call this a system of equations, and solve for the variables x and y. And actually on the screen what I have is actually two different problems, and I want to start with the problem on the right, the system of equations in the red. And first of all, I'm going to start off with a review before we actually get into this topic, which is called elimination. Now before, we've talked about substitution. So for example, the system of equations that I have in the red, I'm going to solve these for the variables x and y by using substitution. And the way we started this off was we said that, all right, we kind of know what y is equal to. Y is equal to x plus 2. So x plus 2, that value is what y is. And then what we did, we took that x plus 2 and we substituted it into the other equation for y. So in other words, I'm going to replace the y in this second equation with the value of x plus 2. Now x plus 2 is one value, or sometimes we phrase it as a couple. So in other words, we have 2x plus 3 times whatever y is. Well, in the top equation, y is x plus 2. So I have parentheses because it's a couple. And I have 3 parentheses x plus 2 then is equal to 11. Now what I've done here through substitution is that we've actually created an equation that has just one variable. It has the variables x, and we can solve it. So I have 2x plus, now I'm going to distribute the 3, so 3x plus 6 is equal to 11. And then continue simplifying, I have 5x plus 6 equals 11, and now solve it for x. They're adding 6, so subtract 6, so 5x is equal to 5, and finally divide by 5, and x is 1. So x has the value of 1. Now I can go back to either equation and I can substitute 1 in for x and figure out what y is. Well, probably the easiest one would be this one. So y is equal to whatever x plus 2 is. Well, since x is 1, 1 plus 2, y is equal to 3. And that is substitution. Now what I have shown on the right, and I just want to briefly just kind of show or review how we started these. On the right, I really don't have one equation where y is equal to something or x is equal to something. I don't have an equation like that like I had here. So what we did is we looked at both equations, and again I'm doing the system of equations in the black. We looked at both equations and we asked ourselves, is there a letter x or y where there is not a number in front of it? And the answer to that is there is. So actually this doesn't have a number in it, and this doesn't have a number in it. So the top one I could solve for x, or the bottom one I could solve for y, and kind of get an equation that's in that form. I'm going to take the top one. So I'm going to take that top one, and I'm going to solve x plus 2y being equal to 0. And I'm going to solve it for x. So let's see, they're adding 2y, so I'm going to subtract 2y. So we have 0 minus 2y. So x then is equal to, let's see, 0 minus 2y is a negative 2y. Alright, so what I have is x is a negative 2y. So now I can replace x into the second equation. I can substitute a negative 2y right into the second equation and do the same thing as what I did over here. And anyway, that is a kind of a background on substitution. Sometimes substitution can take a while, and that might be the benefit or the advantage of using this new topic called elimination. All right, let's take a look at example 1. And now we're going to talk about solving a system of equations by using elimination. Now, my system of equations, I have x plus 2y equals 8, and I have 5x minus 2y equals 4. The whole idea of elimination is that we're going to, we want to try to eliminate one of the variables, and that's why it's called elimination. We're trying to eliminate one of the letters. So I'd like to either eliminate x or I'd like to eliminate y. And if we're able to do that, then I have these equations down to one letter, and I can solve for one letter just like we did with substitution. So what I'm going to show you here, first of all, is notice that look on the, well, first of all, let me explain. We want to look at this system of equations in terms of columns. So notice here on the left I have columns of x, and I'm going to use the marker here. So here I have, if I move straight up down, I have an x column. Here, if I move straight up and down, I have a y column. And finally over here, I just have what we call constants, or just numbers. Now when we use elimination, we add the columns. Alright? So what I'm going to do is I'm going to simply add the columns, because I notice that something's going to happen. So I'm going to put a big plus sign right here, and I'm going to add the columns together. So in other words, the top one I have x. Remember, that's 1x or x. So what's 1x plus 5x? Well, that's 6x. Alright? Now what happens when I take this 2y plus a negative 2y? So what's 2y plus, and remember this is a negative, right? It's a minus. If I wrote that out, 2y plus, because again we're adding the columns, what's 2y plus that negative 2y? Well, they cancel. And I don't have anything. I don't have anything for a y term, so they completely cancel out, and that's a good thing. And then finally, it's equal to, I add the constants, 8 plus 4 is 12. Now look at what I have. I have an equation that I can solve. It's one letter. So let's see, they're multiplying by 6, divide by 6. So x is equal to 2. Well, now I know what x is. X is 2. Now I can substitute 2 in for x into either equation and then solve it for y. I'm going to pick this one. It seems like it's a little bit more simple. So I'm going to replace, I'm going to substitute 2 in right up into this first equation. So I have 2, because I put 2 in for x, plus 2y equals 8. Or in other words, 2y plus 2 equals 8. Now solve it for y. They're adding 2, subtract 2, so 2y equals 6, and finally divide by 2, y is equal to 3. So my solution then would be, and I'm going to write it as an ordered pair, is 2, 3, with x being 2 and y being 3. Now this example was pretty straightforward, because all I had to do is add the columns together, and I had a variable that did eliminate. Now let's take a look at example 2. If I add those columns together, so I'm going to put a big plus sign, because remember, when we use elimination, we add columns. Now if I added the columns right now, let's see, and I'll write this out, and this isn't going to work with this one. 3x plus 2x is 5x. 4y plus 3y is positive 7y. And already I can see one of my letters did not eliminate. So this is where it does get a little bit tricky. I need to do something to the first equation, and I'm going to label this first equation as equation 1, and the second one as equation 2. So what could I do what could I multiply one of the equations by, or both of them by, so that when I did add the columns together, a letter is going to eliminate? And you know what? There's unlimited ways I could do this. Okay, this would just be one example. I'm going to take equation 1, and I'll just put the 1 here, and I'm going to pick a letter I want to eliminate. Either I'm going to pick x to eliminate, or I'm going to pick y. I'm going to pick x. It doesn't matter. I'm going to pick x. And I'm going to multiply the first equation by a negative 2. And I'm going to multiply the second equation by 3. Alright, so let's keep that in mind. So the first equation, I'm going to multiply that first equation by 2. Now remember, if I multiply one of the terms by 2, I got to multiply everything by 2. Remember that magic, that golden rule, what I do to one, I got to do it all. So let's see, 3x times a negative 2 is a negative 6x. Positive 4y times a negative 2. 4y times a negative 2 is a negative 8y. And a negative 7 times a negative 2 is a negative 14. oh, excuse me, it's a positive 14. Negative times negative is positive. Now I'm going to take the second equation and I'm going to multiply everything by 3. So 3 times 2x is 6x. 3 times 3y is a positive 9y. And 3 times a negative 6 is a negative 18. Now, in doing so, look at what happened. Now when I add the columns together, notice that I get a letter that eliminates. What's a negative 6 plus 6? You know what? They eliminate. It's 0. It's nothing. What's a negative 8y plus 9y? Negative 8 plus 9 is a positive 1y, or just y. And I'm going to keep that in the same color as what I had before here. So a negative 8 plus 9 is 1y, or just y. And then what's 14 plus a negative 18? That's a negative 4. So now I was able to get a letter to eliminate. Y is equal to 4. Now how do I figure out what x is? Well, I simply pick one of these equations up here, and I substitute negative 4 in for y, and I solve it. I'm going to pick the second one. It just seemed, for some reason, it just seems easier in this particular problem. So I'm going to take 2x plus 3y equals 6. Let's see. 2x plus 3y equals a negative 6. And I'm going to put a negative 4 in for y. So I have 2x plus 3 times a negative 4 equals a negative 6. So I have 2x, let's see, 3 times a negative 4 is a negative 12, minus 12 equals a negative 6. Add 12 to both sides, so 2x is equal to positive 6, x equals 3. So my solution to this problem then was 3, negative 4. And again, this is only one way of doing this. There's unlimited ways. For example, I could have tried to eliminate the y's. I could have multiplied this top equation by, for example, 3 to give me 12y. And then I could have multiplied the bottom equation by a negative 4 to give me a negative 12y. And then my y's would have canceled out. Okay, one more example. Again, I have a system of equations. We're going to use elimination to solve these. Remember, when we use elimination, you add columns together. All right, so I'm looking at my two equations, and I'm trying to decide, let's see, do I want to cancel out the x, do I want to eliminate the x, or do I want to eliminate the y? And again, it doesn't matter. This time I'm going to eliminate the y. So I want to try to multiply the y's. I want to multiply this by something and this by something so that when I add them together, they cancel. So in other words, I want, maybe, would this work if I multiplied the top one by 5? Let's see, 5 times 2y is 10y. And I'm going to back up because that won't work. Okay, I was looking at a different number. How about this? If I multiply the top one by a negative 3, negative 3 times 2y is a negative 6y. And how about if I multiply the bottom one by 2? What's 2 times 3y? 6y. So on the top I would have a negative 6y, and the bottom I'd have a positive 6y. And what's a negative 6 plus 6? That would do it. They would eliminate. So let's do this. Let's take the top equation and let's multiply everything by a negative 3. So negative 3 times 5x is a negative 15x. A negative 3 times 2y is a negative 6y. And a negative 3 times a negative 3 is a positive 9. Now on the bottom equation, let's multiply everything by 2. 2 times 2x is, I forgot my x there. 2 times 2x is 4x. 2 times 3y is a positive 6y. And 2 times a negative 10 is a negative 20. Now let's see if this works. Let's add the columns. So a negative 15x plus 4x is a negative 11x. What's a negative 6 plus 6? They cancel. It worked. Equals 9 plus a negative 20, a negative 11. Looks like we're in good shape. Now solve it for x. X is equal to 1. Now pick one of the equations to substitute 1 in for x and solve it. I'm going to use the second one. All right, so, and then we'll have this. So I'm going to put 1, I'm going to substitute 1 in for x right there. So I have 2 times 1 plus 3y equals a negative 10. So 2 plus 3y equals a negative 10. Or in other words, 3y plus 2 equals a negative 10, just by rearranging it. Now they're adding 2, subtract 2. So 3y, let's see, a negative 10 minus 2, negative 12. Now divide by 3, y equals a negative 4. My final solution is 1, negative 4. Now again, I want to emphasize this is one way of doing this. Don't get locked into saying that's the only way I could do this. I chose to multiply the top one by a negative 3 and the bottom one by 2 so that I got a negative 6y and a positive 6y. I could have multiplied the top one by let's see, 6. Or excuse me, I could have multiplied the top one by 6 and the bottom one by 4 so that I got a 12y and a negative 12y. Or I could have picked on the x's to eliminate them. All right, so this is called elimination. Once you get the hang of it, I think you'll see that you like it better. It can be less time consuming than substitution.